This is my infinite tree generator. Though simple at first glance, trees hide an incredible amount of complexity, and the deeper I searched, the more I discovered. Today, I'm going to code a simulation that attempts to generalize one of Earth's most ubiquitous natural fractals. Alright, you capitalistic, one-slurring O'Harians. This is how we're gonna cook up some delicious trees. Ingredient 1, segments. Each tree is divided up into segments of various lengths and radii to build the tree up one piece at a time. Each segment's direction is dictated by a numbered vector. Ingredient 2, divergence. Most trees are a bit crooked, so in order to account for it, every time a segment grows or splits, the new segment vector will diverge from the previous one by a certain angle. Ingredient 3, recursion. When a branch splits, it will usually carry out the same instructions as its parent branch, just on a smaller scale. This creates the general tree shape, where every smaller branch bears resemblance to the whole. And that's it.
My lord, the VCs are fully invested.
Good. Now they will witness the power of this fully operational Finid factory.
In order to get the second ingredient, divergence, I need to figure out how to rotate one vector around another, and I think Unity already has a function for this, but I wanted to give it a shot myself just as a fun little mathematical challenge. Which means we're going on a side quest! First we start with a stationary vector and a rotating vector, then we create two orthogonal vectors to the stationary vector by performing a cross product 2 times, giving us a plane perpendicular to the stationary vector, then we project the rotating vector onto the stationary vector's direction to get our final rotated vector. Boom! Now that that's done, it's time to code up some scripts to visualize it. These first ones will be to show how we can create any vector by rotating a vector of arbitrary length on one axis around both of its two orthogonal axes. So we'll start off with our 3 base axes, x, y, and z, and create a line extending z straight out. Now I'll add a function to my visualizer script that draws a continuous line through a list of points. And boom! Look at that, we got a 4! Now by rotating our elongating z vector around the y-axis, we can cover all points in the zx plane. Now we add rotation around the x-axis. And by combining the two into one, we can cover all vectors in the xyz field. Now we should be able to rotate our... Whoa, wait, hang on. I'm missing something. I actually can't figure out how to do this fully. Hang on, let me see what Wikipedia has to say. Okay. Ooh, hello. You're looking like a cute little mathematical fact. You like candy? I got some candy in the back of my clipboard.
My parents said I shouldn't talk to strings.
Just get in the clipboard!
Yep, that should do it. Oh lord, forgive my signs. Now we can visualize the black arrow as the stationary vector, the white grid as the plane perpendicular to it, and the magenta arrow as the rotating vector. Then we can specify a certain angle and get the blue arrow as our final vector. Get rotated, vector scum! With that done, I think it's time to start drawing some little cylinders for our tree segments. I've written up this script, and now we should get a nice big line, apparently. Hey look, it's a sun! Okay, now it's good. Or, you know, you could just quit halfway through, sure. Apparently our abs are invalid. There we go, that's looking very nice. We can also modify it to draw tilted cylinders like so, and just look at how thick this boy is already, but now I've added parameters to specify the start and end radii. What is this, a ballerina? I fixed that, and for the next customization, I've added the ability to change the normals of the cylinder faces, although in some cases it seems to lead to these weird twisted tubes. This one's either a bowling pin or that one YouTube thumbnail. I made the lines thinner so it's easier to see, but from some angles it appears normal, while from others it twists in on itself. I found after building this twisty nuclear bomb that it even changes depending on which direction it's being drawn in, which was kinda strange. I found a fix for that too though, and now I just have a nice straight nuclear bomb. Now the foundation is laid for the rest of the project, and we can jump right into creating the actual tree class. The base tree class is done, haven't added branching yet, and now I have these segments growing up into the sky. Still going, I guess. What do you know, it kinda does look like one of those truffula trees.
Finide factory.
And only one error. I'll take it. Should be fixed if I just add a dash of F. Oh, never mind. Apparently F stands for freeze the entire program. Now it's time to add the branching logic in. Who needs to go outside to touch grass when I can simulate my own? And looks like the branching works. It's a bit lopsided towards the top, but I have a few ideas on how to fix that. Otherwise, I'd say it's taken shape pretty well. So I've modified the algorithm so that the branches grow relative to the thickness of their parent branches, and it's still a bit tall, but I'm not worried so much about that. What I am worried about is the horrible FPS I'm getting. You can see in the top right corner I'm hovering at about 2 to 3 FPS at the moment, probably because my visualization script is spawning a whole new object in the scene every time it creates a line, which isn't scalable anymore for this project. So I'm creating this compute shader which we can send data to from the CPU to process my line positions, which should make it much faster. Wait, that's actually like 10 times slower. What's going on? We're losing him, sir. 0.3 FPS. 0.1 FPS. He's gone, sir. Yeah, I think the method I used was still very inefficient, so I'm switching to a different method that combines the compute shader with a vertex shader. The GPU uses the compute shader to process the line positions as they're drawn, and the vertex shader to actually render them, which should in theory be much better than using thousands of objects with trail renderers. I gave the tree a brownish orangish color, and now that's drying much more smoothly. I also made it so each segment is hexagonal to save on how many lines have to render. And with that change, we're getting a nice, wait, 20 FPS? No, surely we can do better than that. Something's still not quite aligned. Also, don't ask what happened to this guy, because honestly I don't remember, but I thought it was a cool looking random bug. I think most of the lag is caused by sending line data to the GPU every frame, so I've added a condition to stop doing that once all the lines are drawn. And oh dear. All my lines are disappearing now. I had to modify the way the GPU buffer data was being handled, and now finally the trees are drawing nicely at a more expected 60 FPS. The next step is to make our trees fully customizable. So I've added these funks, which allow for changing almost any characteristic of the tree based on the segment numbers. Any outside script can spawn a tree with its own custom funks, or down here are the default funks if none are specified, which gives us this as our default tree. Ooh, you're kinda gnarly looking, aren't you? I'll have to tweak the defaults a bit more. Now this is our default tree. And then it disintegrates, and we can spawn a new one. Wait, did you see that? Hang on. What are those flickering lines? Oh boy, looks like I still have some issues with misbehaved GPU buffers. And the issue was apparently that I needed to sync the data to the GPU after removing some lines, which is why the first tree had no flickering, but the subsequent ones showed leftovers of previous trees as they grew. I don't know about you, but I'm getting a bit bored of all these dull colors and the default Unity skybox, so I'd say it's time to go shopping for a new one. Ooh, limited time offer. You can get all this for $1? Alright, let's not get distracted here. We're on a budget, kids. Daddy needs to afford his rent. Hey, an AI skybox generator. This looks pretty slick, and it's free? I think I'll try it out. Oh wait, never mind. You need a subscription to use it. Oh well, looks like we're going with this other freebie series. These aren't too shabby, so I'll take it. I like this moody ambient skybox, so I'll plop that one in and change it to a charismatic sunset orange. I've also added some bloom to make our lines stand out with a bit of glow, and now it's looking a bit like Tron 1982, which I'm cool with. It still freezes up if too many lines are added to the buffers, but at least it can handle a few thousand much better than my first method. I am still having some issues with branches appearing twisted under certain conditions, so I've modified the cylinder drawing script again to... oh, apparently that just makes everything twisted. It's actually kind of neat though, like a crystal, or maybe a Tootsie Roll tree? After fixing that, it was literally one number. The branches are now nice and straight, and I spent a bunch of time trying to see if I could add a rendering order for the lines based on their distance from the camera. But after realizing that this faint grid that Unity draws in the scene by default doesn't even worry about the rendering order, I just decided to leave the code as it is. If Unity doesn't worry about rendering order, why should I? For the final showcase, I've created unique functions for various trees, some of which exist in real life, none of which are to scale, but I did my best to be somewhat accurate as far as their shape. Of course, they have no leaves, which I've decided to save for a separate part 2 of this video. So without further ado, enjoy the show. If you enjoyed this project, don't forget to check out part 2 when it's released, or my previous build about flow field pathfinding algorithms if it hasn't. I'll see you there.